Okay, now let's look at question number 3. So the question asks us to determine the acceleration of the cabinet and the normal reaction on the pair of rollers that have negligible mass. Okay, so the difference here is that the trolley is now moving and on an inclined surface. So we start with the free body diagram. So of course there will be weight mg, but bear in mind that weight is always pointing down, although the trolley is moving on an inclined surface, but the weight must always be pointing down and not following the inclined angle. And there is a contact point at A, so there will be a normal force at point A as well as a normal force at point B. And this time, to make the calculation easier, note that we have defined x and y axis slightly differently. So because we know that the trolley, the cabinet, will be moving in this direction because of the gravity, so once it is released, it will be going down. So we set the x-axis as positive, pointing down at an inclined angle like this, and the y-axis is pointing up, positive, like that. Okay, so now the free body diagram is done. We move on to the kinetic diagram. So obviously the cabinet is not going up or is not going to rotate, so it will only have one arrow in the kinetic diagram that is moving downwards at this inclined angle. So by doing this axis, tilted axis like this, so this will definitely make the calculation easier. So let's say if you define the axis like this, so like the normal way, x and y. So in this case, you will not only have x-axis movement, magx, but there will also be a y-axis movement like this. This will be magy. So by doing this way, the axis, you avoid from having two arrows in the kinetic diagram, and that will definitely ease the calculation. So let's remove all this. Okay. All right. So the first step is always to use three basic equation that we have. So we start with the sum of forces in x-axis equal to magx. So here you can notice that we have to separate this mg into two components. So this will be mg cos 15 degrees, and here will be mg sine 15 degrees, right? So there we have, in x-axis, this is mg sine 15 degrees equal to what we have on the kinetic diagram, which is this magx, so 80 kg times agx. All right, so next we straight away will get the value of ag, that is 2.539 meter per second square. Next we move on to total of force in y-axis. So we have three forces in y-axis, NA and B and mg cos 15. So NA and B is positive, minus mg cos 15 equals to 0 because we don't have anything on the kinetic diagram which is acting in y-axis. and therefore we have NA plus NB equals to 758.06, but we don't know what is the value of NA and NB, so we have to move on into the third equation, which is the moment calculation. So the total moment equals to 0 because there is no rotation, and we have NA times 0.5, which is this, and this is going let me change the color, and this is going like this, counterclockwise. So we set counterclockwise as positive, so NA will be positive, and this going to G is clockwise, and this is the distance, so this will be negative, equals to 0. So we have NA equals to NB, which is equal to 379 Newton.